Welcome to the debate. Today, we're diving deep into really one of the most critical questions shaping the future of artificial intelligence. Should this powerful, genuinely transformative technology be developed and deployed primarily through open source, collaborative models? Or does its immense potential, and let's face it, its inherent risks, demand a more controlled, proprietary approach?
Exactly. And we'll be exploring the underlying philosophies here, the technical realities, and the broader societal implications of this split, drawing on this source material.
Right. So, as the advocate today, I'll be making the case that an open source model is, well, the optimal path. It fosters rapid innovation, ensures safety through transparency, and really democratizes access to AI for everyone.
And I'll be arguing that while that open source ideal is certainly admirable, we need to look at the reality. Proprietary, controlled development is, I believe, essential for properly managing the profound risks of advanced AI, ensuring centralized oversight, and consistently delivering that cutting-edge, reliable performance the market actually demands.
Okay, so my position is this. The most effective, the most robust, and ultimately, I think the safest path to a beneficial AI future lies squarely in open source development. This approach, and you see figures like Jan LeCun championing this, it just inherently fosters collective innovation. I mean, imagine a global community, hundreds of thousands of researchers, developers, all able to scrutinize, test, enhance the technology. That accelerates improvements, sure, but critically, it identifies biases, vulnerabilities, potential flaws far more effectively than, any internal corporate team, no matter how brilliant they are. This transparency, this decentralization, it naturally democratizes access to really powerful technology, preventing a dangerous monopoly by just a few big corporations. And economically, open source AI drastically cuts costs for startups, for small to medium businesses. It allows them to build specialized, highly defensible products by fine-tuning these open models on their own unique proprietary data. LeCun argues quite consistently that openness is inherently safer because it subjects models to the scrutiny of thousands. And he also makes the point that a diversity of AI assistants is crucial for a healthy ecosystem, and even for geopolitical resilience. We see this playing out, vividly in the grassroots community. Places like our local LLMA forum online, they're actively driving innovation through techniques like quantization, which, basically optimizes models for faster, more efficient performance, even on less powerful hardware, and these parameter-efficient fine-tuning methods, PFT, like LoRa. These methods let you customize models with much less computational grant, much less data. It makes advanced AI accessible, customizable, even on consumer gear, bringing powerful AI right to the edge for privacy, control, and, significant cost savings.
Okay, but I come at it from a fundamentally different perspective. The sheer power of these advanced AI models, especially as they, rapidly approach something that looks like human-level intelligence, it just demands a controlled proprietary development model. This approach, and you see it championed by pioneers like OpenAI, like Anthropic. It ensures centralized oversight, and that, I argue, is crucial for mitigating potential misuse. It also enables faster, more focused development cycles. You don't have the overhead of coordinating a massive global community, and it ultimately delivers highly polished, reliable products that can actually stand up to serious enterprise-level demands. Advocates like Sam Altman at OpenAI, Dario Amodei at Anthropic, they argue pretty forcefully that the potential for catastrophic misuse by bad actors is simply too great to allow unrestricted access to these frontier models. That makes centralized control for them a kind of moral imperative for safety.
Anthropic's responsible scaling policy, for instance, with its explicit AI safety levels, the ASLs, that demonstrates a proactive, structured framework. It's designed for managing risks as capabilities inevitably increase, even to the point of pausing development if dangerous capabilities pop up. And look, while open models are quote-unquote free to download, the total cost of ownership, the TCO, for self-hosting is substantial. You're looking at serious investment in powerful GPUs, cloud infrastructure that can easily run $10, $20 per hour, just for a big model like Llama 3 70B, plus a dedicated team of pretty expensive ML engineers. For many businesses, this often makes API-based solutions, frankly, far more practical and truly cost-effective. And let's be honest, the top-tier closed models generally do maintain a performance edge in complex reasoning tasks, offering more mature, seamlessly integrated features that are essential for those cutting-edge applications.
Okay, so let's dig into that. You mentioned managing risks, the idea of centralized control being a prerequisite for safety. That seems like a core tension here. How do we actually ensure safety and robust governance? Is it through that centralized oversight you're advocating for, or is it through more distributed scrutiny?
Precisely. My argument hinges on the idea that given the potential for, catastrophic misuse of highly capable AI, that centralized control through managed APIs like OpenAI and Anthropic are doing it becomes an absolute prerequisite for safety. OpenAI's Sam Altman explicitly frames their proprietary control as a direct response to the increasing power of these models and the need for iterative managed deployment. We mentioned Anthropic's responsible scaling policy, defining those AI safety levels, even pausing development if dangerous capabilities emerge. That's a really concrete, proactive example of how centralized stewardship can prevent devastating outcomes, especially when you think about dual-use capabilities, like, say, the potential for creating biological weapons. The risks are just, I think, too high for a free-for-all. A single, accountable entity can respond much faster and more effectively than some disparate group.
I understand the appeal of having a single accountable entity. I really do. But let me offer a different perspective on this. Jan LeCun argues pretty powerfully, I think, that openness is inherently safer because a global distributed network of researchers can, just by sheer numbers and diversity of viewpoints, more effectively scrutinize and identify biases, flaws, security vulnerabilities than any internal corporate team ever could. Concentrating that much power and the responsibility for safety in just a few labs, well, LeCun argues, and I tend to agree, that that is itself a profound and often overlooked risk. You brought up the Pandora's box problem, and yeah, I'd agree that once a powerful AI capability is released, its effects are irreversible. But what exactly is irreversible? Is it just the model weights themselves, or is it the knowledge derived from them, the capability itself? That feels more like the true Pandora's box. And if distributed oversight is the answer, it's really about preventative measures from the absolute outset, not reactive control after the fact. It's about trying to prevent the box from being opened carelessly in the first place, rather than scrambling to stuff everything back in once it's already out there.
Look, while I understand that philosophical stance on Pandora's box and the ideal of widespread scrutiny, the practical reality is that coordinating a global distributed network for truly critical safety issues, that presents immense logistical and governance challenges that a centralized model is explicitly designed to overcome. How do you ensure accountability across thousands of different actors, many of whom might have conflicting ethical guidelines, or frankly, even malicious intent? And maybe more importantly, how do you ensure a rapid response, a coordinated mitigation, if a genuine safety risk emerges from an openly developed model? A centralized authority with the resources and the clear mandate can act with a speed and a cohesion that a distributed network simply can't match when it comes to containing a truly dangerous capability.
My concern with that line of reasoning, though, is that centralized control can often foster a kind of false sense of security. It gives the appearance of safety, while potentially creating a single point of failure, and, maybe crucially, a lack of external pressure to actually address issues proactively. Distributed scrutiny isn't about uncontrolled chaos. It's about making safety a collective, ongoing effort. The rapid response you mention in a closed system often means after a problem has already emerged internally, whereas an open model under constant community review arguably has a much higher chance of issues being identified before they become widespread catastrophic threats. So it's really about proactive identification versus reactive containment.
Okay, let's pivot slightly then. Let's talk about performance. You champion open source innovation, which is fair, but for many critical applications, sheer capability still reigns supreme, right? While open-source models are definitely advancing rapidly, proprietary systems like OpenAI's GPT-4o generally maintain a measurable performance edge in crucial benchmarks. For instance, GPT-4 scores, 86.4% on MMLU. That's a benchmark assessing general knowledge and reasoning across like 57 different subjects, compared to Llama 370B's 79.5%. And on GSM-8K, which focuses on complex grade school math problems, GPT-4 gets 92.0% versus Llama 3's 79.6%. Now, these aren't just academic numbers. These scores often translate directly to more reliable, more precise output for broad, generalist tasks. Plus, closed models benefit from more mature, integrated features, things like native function calling, advanced multimodality, which are really essential for building the complex, reliable applications that enterprises actually require. This focused, centralized development, quite simply, ensures the highest quality, most capable generalist AI available today.
But isn't there a kind of a fundamental flaw in relying so heavily on those specific benchmarks, especially when we're seeing more and more discussion about issues like benchmark contamination? How do you square that circle with the dramatic real-world speed advantages we see in open source? Those benchmarks, they're increasingly facing questions about contamination, meaning the models might have accidentally been trained on parts of the test data itself.
That is a fair point, yeah.
Right? So that makes them less reliable for measuring true generalized reasoning because they're basically being tested on something they've already, in a sense, memorized. Qualitatively, we've seen evaluations where Llama 3 actually shows like 15% higher performance and Python coding challenges compared to GPT-4. And those are real-world problem-solving scenarios. But maybe more critically, open-source models really shine where speed is absolutely paramount. Llama 3 running on optimized hardware like Grok's inference chips can hit 309 tokens per second. That is nearly 9 times faster than GPT-4's reported 36 tokens per second. This huge drop in latency isn't just, a small improvement. It unlocks entirely new categories of real-time applications that closed models just can't handle right now. And again, the open source community, through things like quantization and PEF-LoRa, makes powerful models accessible and customizable even on regular computers, driving this massive wave of innovation from the edge.
Okay, well, that's an interesting critique of some benchmarks, and speed is definitely important for some things. The fact remains that for many, maybe most enterprise use cases, consistency and accuracy in general reasoning across a wide range of tasks are more critical than just raw speed in perhaps niche areas. Benchmark contamination is a valid concern, yes, but I don't think it entirely invalidates the overall trend that top-tier proprietary models developed with enormous resources often do lead in generalized, complex problem-solving. We're talking about models that need to parse nuanced legal documents, or maybe provide precise medical insights, where even a marginal difference in accuracy can have really significant consequences. So the question is, are we prioritizing a few specific speed-intensive applications over the broader, more reliable utility that these advanced closed models offer for the majority of complex enterprise needs?
See, I'd push back on calling it niche areas. I think the innovation happening at the edge isn't niche at all. It's fundamentally transformative. What the open source community is demonstrating, I believe, is that for a huge array of specific real-world tasks, you can get comparable, sometimes even superior performance at a fraction of the cost and with much, much greater control. The generalized reasoning you champion often comes with a significant trade-off in efficiency and cost. For many businesses, a fine-tuned specialized open model, even if it lags slightly on some theoretical general intelligence benchmark, will actually deliver far greater performance per dollar and much more relevant results for their specific data and applications. Which I think brings us nicely to our final point, the whole question of economic value and strategic advantage.
That's a compelling argument about performance per dollar, but let's really consider the full economic picture, especially for businesses, and that total cost of ownership, the TCO, we touched on. For many organizations, particularly those without deep in-house ML expertise or big capital budgets for hardware, the transparent pay-as-you-go API pricing of closed models is exceptionally attractive. Highly capable models like GPT-4o Mini are available for as little as $0.15 per million input tokens, that offers a really predictable operational expense. Whereas open source models, while free to download, their TCO, as I said, is substantial. It includes that upfront investment in GPUs, significant cloud hosting costs, and crucially, that dedicated team of expensive ML engineers to manage, optimize, secure these things. For many companies, the sheer cost and complexity of self-hosting just outweigh the perceived free benefit.
They prefer the simplicity and the scalability of just using an API.
The free label for open source is, yeah, it's a bit of a misnomer in terms of direct cost. I'll absolutely grant you that. But the economic argument for open source becomes overwhelmingly strong when you really look at that performance per dollar equation over the longer term. For many types of workloads, Llama 3 7db can deliver performance comparable to GPT-4, but at a cost much closer to GPT 3.5. And if you access it via third-party API providers who host these open models, it can be up to like 8 times cheaper for input tokens compared to GPT-4 directly. But more importantly, open source AI is just this powerful catalyst for economic growth and innovation right across the board. You see studies showing 89% of organizations are already using open source components, and 2/3 find it actually cheaper to deploy overall. The real defensible competitive moat isn't created by the base model itself. It's created by fine-tuning an open model on your own proprietary unique datasets. That creates specialized intelligence that nobody else has.
Think about a big bank like BNP Paribas. They're increasingly using open source models like Mistral for secure internal customer support. Why? Because by self-hosting and fine-tuning it with their own sensitive customer data, they get a level of security, compliance, and IP protection that, frankly, an external public API just cannot offer. This completely transforms AI from just another line item and operational expense into a compounding strategic asset. It enables critical enterprise applications like retrieval augmented generation, RAG systems for confidential documents in law firms, for instance. It's fundamentally about control, customization, and building long-term value. I'm still not entirely convinced that performance per dollar universally favors open source once you properly factor in the full TCO for every type of enterprise. While that specialized competitive moat sounds great in theory, for the, let's say, vast majority of businesses that just want to consume reliable AI capabilities without becoming a full-blown AI engineering firm themselves, the API convenience and that predictable operational expenditure of closed models remain incredibly appealing. Not every company has the resources or even the strategic need to build and maintain their own complex AI infrastructure just for customization. Many are just looking for a plug-and-play solution that works at scale. And for them, the perceived strategic asset of self-hosting could very quickly become a significant liability in terms of cost and complexity.
And I think that's where the nuance really lies, doesn't it? It's about discerning between AI as a commodity service versus AI as a core strategic capability. If you just need general text generation, yeah, an API is probably fine. But if you're dealing with securing sensitive data, ensuring compliance in regulated industries like finance or healthcare, or creating truly unique, specialized applications that actually differentiate your business, well, then the control and customization offered by open source models turns what would be a recurring operational cost into a genuine long-term strategic investment. And that's a profound shift, I think, in how businesses can leverage AI, moving beyond just consuming it to actually owning and innovating with it. So we've explored this intense, philosophical, but also very practical debate between open source and proprietary AI. I've made the case for open source as really a democratizing force, something that drives innovation, enhances safety through transparency and that distributed scrutiny, and creates significant economic value through specialization and control.
And I've presented, I think, a strong argument for the necessity of proprietary, centralized control, primarily to manage the profound risks of increasingly advanced AI, ensure safety through clear lines of accountability, and deliver that top-tier, polished performance needed for a broad range of generalist applications.
Yeah, and while the market is definitely showing, a trend towards hybrid architectures, trying to get the best of both worlds, maybe the underlying tension about where we should fundamentally place our trust. Is it in centralized institutions or is it in distributed community oversight?
that remains, I think, a really critical point of divergence in the whole conversation about AI governance.
Absolutely. And as society continues to grapple with how to govern this incredibly transformative technology, understanding these distinct perspectives is paramount. The journey into the future of AI is clearly far from settled, and there is undoubtedly much more to explore in the material regarding these evolving dynamics and what they really mean for how we build and deploy AI going forward.